Okay, for what we have in section 1.5, question number 1, it says to write equations for the horizontal and vertical lines passing through the point -2, 1. Okay, now for ordered pairs, now we have with coordinates, okay, they are of the form x and y. Now for horizontal lines, okay, this will be in reference to the behavior of the graph traveling along the y-axis. Okay, so we have in this particular case, right? So we have in this particular regard, okay, so we have for horizontal lines, this will be in reference to y values, vertical lines will be in reference to x values. So we have for the horizontal line, okay, we have that y is equal to 1. And for the vertical line, this will be in reference to the x values. So we have that x is equal to -2. Now for question number 2, okay, we have a line that passes through the point -4, 6 and has a slope of 5/2. And it says to write an equation in point slope form for this line. Okay, so we have for the point slope formula, again, we have y minus y01 is equal to the slope m times the quantity of x minus x01. Okay, now we have the tools at hand. Okay, so you have a slope of 5/2. So you have slope m is equal to 5/2. For -4, 6, okay, x01 will be represented by -4. y01 is going to be represented by 6. So just substituting what we have here. So we have y minus y01. So this is going to be y minus 6. For the slope m, we're going to have it 5/2. And for x minus x01, we're going to have x minus -4. And cleaning up the subtraction of negatives, we have y minus 6 is equal to 5/2 times the quantity of x plus 4. So that is going to be the point slope form of the equation in reference to this line. Okay, not the slope intercept, but the point slope form. Now, for question number 3, okay, we have a little history to repeat. Okay, we have with the ordered pair 3, 5. 3 is in reference to x. Y is going to be in reference to 5. So for the vertical line, anything that passes through the y value of 5, okay, we're going to have as well as, so for y is equal to 5, okay, that's going to be for the horizontal line. And for the vertical line, this will be in reference to x values. So for the vertical line, we have x is equal to 3. Now, for what we have in question number 4, it says to consider the line y is equal to 4x minus 6, and we're looking for the slopes of the parallel and perpendicular lines. And now for y is equal to 4x minus 6. Okay, now we have in the case of the slope m for this given line, slope m is equal to 4. So for slope of the line that is parallel to this line, again, parallel lines are going to have the same slope. So again, so for the slope of this line, we're going to have it 4. Now, for the slope of the line that runs perpendicular, again, now we have for this particular slope, again, instead of having the same slope, we're going to have the slope value of what we have for the perpendicular line to be the opposite sign reciprocal of that which is in reference to the given line. So the opposite sign reciprocal of 4 is going to be the slope of the line that runs perpendicular. So we're going from a positive to a negative, and then taking the reciprocal, we have minus 1/4. Now, in question number 5, okay, we have considering the line 5x minus 8y is equal to 7. Now, if I'm looking for the slopes, okay, now for 5x minus 8y is equal to 7, I'm going to go ahead and express this equation in slope-intercept form. So in moving the 5x over, I'm going to have negative 8y is equal to negative 5x plus 7. And we're dividing by negative 8. So for the slope-intercept form, okay, so we have y is going to be equal to 5/8 of x minus 7/8. So we have, for the given line, okay, so the slope is equal to 5/8. And I can transfer this number over to the slope of the line that runs parallel. So for the parallel line, okay, the slope is going to be at 5/8. Now for the perpendicular, you have an opposite sign reciprocal, so this will be the negative of 8/5. Now, in terms of what we have regarding question number 6, okay, so we have a scatter plot. Okay, and it says that the scatter plot data shows the theater revenue and rental revenue for each of 25 movies. Also shown is the line of best fit for the data. And now we have, so for the y-axis we have rental revenue, x-axis we have theater revenue, and it says for these 25 points, as the theater revenue x increases, the rental revenue y tends to. And if you notice, okay, we have for this best fit line, we have a positive slope. So as theater revenue increases, so does the rental revenue. So in this case, it's going to tend to increase. Right. Now, and it says that for these 25 movies, there is, okay, either a positive, a negative, or no correlation between theater revenue and rental revenue. And in this particular case, since they're both increasing, okay, we want to have a positive correlation. Now, it says that using the line of best fit, we would predict that a movie generating a theater revenue of $40 million would generate a rental revenue of approximately how many million dollars? Okay, so we have with the theater revenue, okay, we have at 40, and just taking what we have here. So just looking at the kind of this correlation here. So we have with the theater revenue, okay, so you have at $40 million. And if I were to take what I have here and just line up, okay, with respect to, so we have going on this line. Oops. Let's see, just starting over again. Okay, so we have, in this particular case, for the rental revenue, you have just a tad over $8 million. So we would have, in this particular case, for the best or the closest answer, in this case, this is going to be at 8.5 in millions of dollars. All right, so you got 40 for the number of millions in theater, and you have just over 8 for the rental revenue in millions of dollars. Now, for what we have in question number 7, okay, we have a scatter plot, and this is going to have a downward slope. And now it says to use the equation of the line of best fit, where we have y is equal to negative 0.75x plus 8.65. And for the information, this scatter plot shows the time spent texting x and the time spent exercising y by each of 24 students last week. And it says, what is the best, or I should say, what is the predicted time spent in exercising for a student who doesn't spend any time texting? Okay, so we have for texting, okay, so if you have no time spent texting, okay, so we have in this one, okay, for no time spent texting, and in this one, so if I have the equation of the line of best fit, so we have for the time spent texting, okay, we have in this case, right, so you have y equals negative 0.75 times 0 plus 8.65. So you have y is equal to 8.65. So we have for this particular answer, we have 8.65. Now for an increase of 1 hour in the time spent texting, what is the predicted decrease in time spent exercising? Okay, so we have in this particular regard, okay, so we have, so if I go from 0 to 1, okay, so I have minus 0.75, plus 8.65. And so we're going to have, in this particular case, okay, we're going to have for this particular outcome, again, we have for y, okay, this will be at 7.90, okay. And if you notice, have 7.90, and it says for an hour increase for time spent texting was a predicted decrease in the time spent exercising. And if you notice, okay, we have a drop in the y value of minus 0.75, and this will be in correlation to what we have for slope. Okay, so the slope is negative 0.75, and it says what is the predicted time spent exercising for a student who spends 6 hours texting. So we have, in this particular case, all right, so we have with 6 hours of texting, and then we have just in the correlation here, if I were to use the graph, okay, and you can use the formula too, okay, but in the case, so if I have like negative 0.75 times 6, now I'll just put this up. Okay, so I have negative 0.75 times 6 plus 8.65, and in this case we're going to have minus 4.5 plus 8.65, so you have just over 4 hours. So you have about 4.15 hours. Okay, and you can sort of use the graph. So you have like around 4 hours. That would be okay.